Hello students. So in the previous session we have seen the Fourier transformation of, that means by using the Fourier transformation we can calculate the integral equation, that means we can solve the integral equations if any function is inside the integral. So by applying the inverse Fourier transformation, so that we can determine that function. Okay, so in this problem we'll see the finite Fourier transformations. So finite Fourier transformations. So finite Fourier transformation, that means the length, that means the interval of integration is not as of infinite, it will be a finite. So in infinite Fourier transformation, we have the integration something like minus infinity to plus infinity, correct? But in case of finite Fourier transformations, we have the limits from something like 0 to L, or something like minus L to plus L, or something like minus L by 2 to plus L by 2. Of course these are plus. Something like this. Here it is the length of that interval will be finite. So generally that length itself we call as the period of the function. Period of the function. Okay, fine. So now how we'll define the finite Fourier transformation of a function? See, this Fourier transformation, so let me talk about few words about the Fourier series. This Fourier series will be very familiar to you in your lower standards. So Fourier series. So Fourier series, any function can be represented in terms of the sine and cos terms. Any function can be represented in terms of sine and cos. So a0 by 2 plus sigma n is equal to 1 to infinity an cos of n pi x by L plus sigma n is equal to 1 to infinity bn sine of n pi x by L. This is the function, that is any function f of x that can be represented here 0 less than x less than L, 0 x less than L. So that means here any function can be represented in terms of sine and cosine. So this you might have learned in your BSc Physics first year. So in waves and oscillations chapter, so any function can be represented in terms of sinusoidal wave functions, that means sine and cos. For example, you might have written the Fourier series expansion for a triangular wave function, for a sawtooth wave function, like that. Okay, so now these coefficients a and bn will be obviously that is inverse Fourier transformations here. So let me define what is the finite Fourier sine transformation and the finite Fourier cosine transformation. Okay, so first let's see what is the finite Fourier sine transformation. The finite Fourier sine transform of f of x. The finite Fourier sine transform of f of x. So let's see how we'll define the finite Fourier sine transform of f of x. Okay, fine. So let's say there is an f of x. I want the transformation, sine transformation of the function f of x. So this will be is equal to 0 to L f of x sine of, say for example, n pi x by L, of course integration with respect to x. After performing integration with respect to x, the parameter n is left, that I have sine transformation as a function of n. Here you remember, we know that the time period of this function, the periodicity of this function will be is equal to, only sin x will be there, then the periodicity, that is the time period, will be is equal to 2 pi. But I have here some multiplicators, that is 2 pi upon n pi by L is there. So that is pi will cancel, that is 2L upon n. Okay, something like it is extending. So for example, n the least value will be 1, n can't be 0 here, n can't be 0 here, so n will be the 0, the least value with the time period, that time period will be is equal to 2L, the length will be 2L. So the length will be 2L means we might be performing integration from minus L to plus L, or we might be performing integration from 0 to 2L, something like this. So this is known as the Fourier sine transformation of finite length. What is the inverse finite Fourier transform? Then what is the inverse will be here? Then I define inverse of above transform. Inverse of above transformation. That is, I am taking sine inverse transformation, that is f of s n. Obviously I will get f of x. This will be is equal to 2 by L sigma n ranging from 1 to infinity f of Sn sine of n pi x by L. Okay, so this is the inverse Fourier transformation of sine. Then above one will be the, so this is the Fourier transformation. This is the inverse Fourier transformation. 0 to L f of x sine n pi x by L. Then next one will be f of Sn. Okay, done. So in a similar way, we can define the finite Fourier cosine transformation. The finite Fourier cosine transformation. Cosine transformation of f of x. Okay, so this is defined as, first we will define the Fourier cosine transformation of the function f of x will be is equal to, so it is again the integration from 0 to L f of x cos of n pi x by L dx, that will be is equal to cosine transformation of n. The same manner here also the time period will be same. The time period will be the least value, will take n is equal to 1. Don't take the n is equal to 0. That is n equal to 1. That is 2 pi divided by pi by L. That will be 2L. This will be the time period. So the length of the interval we are integrating. Okay. Now inverse cosine transformation. So this is cosine transformation will be is equal to 1 by L f of 0 plus 2 by L sigma n is equal to 1 to infinity f of Cn cos of n pi x by L. So remember, we are taking x will be from 0 less than x less than L. Okay, so these are the Fourier cosine and sine transformations. So in the inverse formula, I am getting this term as well as this term. So if you compare, this term will be the, if you compare, this term will be the A0 term in Fourier series, and this will be the AN term in Fourier series. So this will be the BN term, this will be the BN term in Fourier series. Okay, so be careful. You're supposed to remember the formulas to understand the things will be in the clearest form. Okay, these are the definitions. Of course, this even can be derived. So, but we don't require that much. We'll give the statements and then followed by the problems related to that. So now we'll take the problems related to this. Now we'll take the problems related to Fourier cosine and sine transformations. So let us take the problems related to this. So I'm taking the first problem. The problems related to this. So the find finite Fourier sine and cosine transform. So find finite Fourier sine and cosine transform of f of x is equal to x square for 0 less than x less than 4. Okay, so this is very simple. The directly will substitute in the formula. Fourier finite Fourier sine transformation will be is equal to f of x is equal to, we have the direct formula, that is 0 to L f of x into sine of n pi x by L into dx. Similarly, cosine transformation of that f of x will be is equal to 0 to L f of x cosine value of n pi x by L into dx. Now you remember here the function f of x will be is equal to x square and the length L will be is equal to 4. The length will be is equal to 4. So now first we'll take the sine transformation. First we'll take the sine transformation. So first we will take the sine transformation, that is sine transformation of the function x square will be is equal to 0 to upper limit is 4. The function is x square sine of n pi x by L, that is 4 into dx. Now we need to perform the integration by parts. That integration by parts formula we know very well. Integration by parts formula uv is equal to u into integration of b minus, so integration of b and a differentiation of u. Okay, so this is the formula. So I require integration of v, that is here it is, I am taking this will be u and this will be v. So what I required here, differentiation of u I require, that is differentiation of u is the 2x, and I require integration of v, that is integration of sine of n pi x by 4 with respect to x. That is integration of v, I'll have sine differentiation will be cos, that is minus 4 by n pi cos of n pi x by 4. These are the things I know very well. Now I'll substitute directly in. Therefore Fourier sine transformation of x square will be is equal to, so by parts we are doing, first one is u into iv, so that is x square multiplied by minus 4x square divided by n pi into cos of n pi x by 4, and don't forget to put the limits from 0 to 4. Then there will be a minus sign, then integration of I am writing here 0 to 4, then integration of b, that is minus 4 by n pi into cos of n pi x by 4, and differentiation of x square, that will be is equal to x, then again with respect to x. So now we will substitute the upper limit. When I substitute the, in place of x 4 will cancel and n pi is there. When I substitute the lower limit, but here also you need to substitute, that is here also, that is lower limit 0, that will become x square, 0 square 0, this of course 1, but 0 into 1 again 0. There is only upper limit will contribute for it, that is minus 4 square will come, that is 4 square will be 64. So minus 64 divided by n pi, so cos of n pi. Only for upper limit it will be contributing. So now come here, this is minus will become plus, this will become 8 by n pi. Then I have 0 to 4, the term x into cos of n pi x by 4, then again dx. So then again, be careful here. You need to perform integration by parts. So in the integration by parts, this is u and this is v. So I require integration of v and differentiation of s. That is d by dx of, so d by dx of x. So that is 1, and the integration of cos of n pi x by 4. That will be is equal to 4 by n pi into sine of n pi x by 4. Okay, fine. Now I'll substitute these values here. So when I substitute these values, the first term will not change, that is minus 64 divided by n pi cos of n pi plus 8 by n pi. So the first term will be integration u into integration of v, that is u is 4x divided by n pi into sine of n pi x by 4. Now I need to substitute the lower limit and upper limit here. So this is a lower limit is 0 and upper limit will be 4. Then there is a minus sign. Then after minus sign, I have to integration 0 to 4. The differentiation of x will be 1. Then integration of that will be is equal to 4 by n pi sine of n pi x by 4 into dx. That will be closed here. So the first term will be remains as it is. That will be is equal to minus 64 divided by n pi, that is cos of n pi. Then now we substitute upper limit, I substitute here. When upper limit I substitute here, sin n pi will be there. So that is plus 8 n pi. So I have 4 into 16 divided by n pi, and that is sin of n pi. Upper limit. The lower limit will be 0, you no need to substitute. Then minus sign will be there. Integration of sine will become minus cos, that is plus the 4 square 16, that is n square pi square, that will be of cos of n pi x by 4 with limits from 0 to 4. Don't forget to put this. So with this, no changes here. That is minus 64 by n pi, there is no changes here. Cos of n pi, so plus 16 into 8, 48 plus 8, 128 divided by n square pi square. First term will be sine of n pi, and next term will be is equal to 16 into 8, that is 128 n cube pi cube. So when I substitute the upper limit, so I have the cos n pi, so the lower limit will be cos 0, that is minus 1. So this is what I got. Now you talk about these terms here, n will be, can't be 0, this is from 1, 2, 3, 4 and so on. N can't be 0, let's say n can be 1, 2, 3, 4. So if this is the case, the sine of n pi will become 0, sine of n pi will become 0. Then what about the cos of n pi will be? Cos of n pi will be is equal to 1 for even numbers. So minus 1 for odd numbers. For example, you check odd number will be 1. That is cos pi, cos 3 pi, cos 5 pi, cos 7 pi. So that's what we leave like this. So this term will become 0. Only this term will become 0. So when I substitute, this term will be 0. Then finally I have Fourier sine transformation. N will be is equal to minus 64 divided by n pi into cos of n pi plus 28 n cube pi cube cos of n pi minus 1. Okay, this is what actually the Fourier sine transformation. So this is the problem of Fourier sine transformation. Now we will go for the Fourier cosine transformation. Now I will go for the cosine transformations. Cosine transformation. The Fourier cosine transformation of the function x square will be is equal to which will again the limits from 0 to 4, f of x is x square cos of n pi x by 4 dx. Then again you need to follow the integration by parts. Now it is very familiar to you, integration by parts. Now you practice. That is 4 by n pi 4 by n pi x square, that is sine of n pi x by 4. This is the first term, u into integration of v with limits from 0 to 4. Then minus, the next term will be integration of, so integration of, that is cos integration will become 4 by n pi sine of n pi x by 4, then x square, that is 2x into dx. Now as usual in the previous case, when I substitute the upper limit, I'll get sine n pi, that is 0. When I substitute lower limit, sine 0 0, or this entire x square 0. Then is finally this is 0, then minus 4 by n pi, that is 2x, that will become 4 into 2, that is 8, you can write. That is finally I have 0 to 4 x into sine of n pi x by 4 integration with respect to x. Okay, fine. So now again we need to do it here with by parts. So that is minus 8 by n pi. The first term will be, so minus 4 by n pi x into cos of n pi x by 4, with lower limit is 0 and upper limit will be 4, minus integration of, so that is minus minus will become plus, so 4 by n pi, that is cos n pi by x by 4. Then integration, differentiation of x is 1 and dx. Okay, fine. Then of course the closed bracket finally to all, the entire closed bracket to all. So then finally I have minus 8 by n pi. When I substitute the upper limit, 4 square, 4 into 4, that is minus 16 by n pi into cos n pi. When I substitute the lower limit, x is 0, then the entire thing will become 0. So this is over. Now come here, then plus 4 by n pi, then one more 4 by n pi will come, then cos integration will be sine, that is sine of n pi x by 4. So with the lower limit will be 0 and upper limit will be 4. So then again you have to careful here, when upper limit will I substitute, that is 4, then sine n pi anyway 0. When I substitute the lower limit, sine 0 will be 0. This entire term will become 0. Then I have only this minus minus plus 16 into 8 will be 128 divided by n square pi square cos of n pi. Okay, so finally we proved. So here, so what is the finally we can write? So the given function will be f of x is equal to x square, that is defined for 0 less than x less than 4. So we solve for the sine transformation of the function. The sine transformation of the function I have. For the sine transformation of the function I have. Finally, the sine transformation of the function will be Fn will be is equal to, I have it will be minus 64 by n pi, minus 64 by n pi cos of n pi plus 128 n cube pi cube cos of n pi minus 1. For the same thing, then what is the, so cosine transformation of n, that will be 128 n square pi square cos of n pi. So these two things will be very important. So then the way we are doing here, I hope it is clear to you. Okay, so be careful. Okay, so we can try one example for you. So for you, so find, so let's say for example, I'm giving you the function the function f of x will be is equal to simply x for 0 less than x less than 4. To find Fourier sine transformation of f of x, Fourier cosine transformation of f of x. So you both determine for only the function f of x is equal to x. Okay, fine. So both sine and cosine transformations are over. So now let us take another example. Another example for Fourier sine and cosine transformation. So another problem I am taking here. Another problem we are taking here. Find the finite cosine transform of finite cosine transform of the function f of x will be is equal to 1 minus x by pi whole square for 0 less than x less than pi. You need to carry the integration from 0 to pi. Okay, so let's see here. Okay, so for the definition, so Fourier cosine transformation they are asking, that will be is equal to 0 to 4, that 0 to pi f of x, that is 1 minus x by pi whole square cos of n pi x by L into dx. But what is the L value here? This L value will be again pi. Substitute that pi. That L value will be pi. So when I substitute that L value is again pi. This will be pi. Okay. And then pi will cancel. Fourier cosine transformation. This will be 0 to pi. So 1 minus x by pi whole square cos of nx dx. Okay, done? Yeah. Now we can solve this. So it is, we have only cos s pi. Yes. We follow the integration by parts. Integration by parts. There is no other option. Definitely integration by parts, we need to go do it. What is the integration by parts will be here. Okay. So this I'll take u. This I'll take b. Okay. Fine. So what will happen to this? The first will be f of Cn will be is equal to. So first term, that is 1 minus x by pi whole square cos will be sine of nx divided by n with the limits from 0 to pi. X is 0 lower limit, x is pi upper limit, minus integration of that is sine of nx divided by n, then differentiation of 1 minus x square. So the differentiation of 1 minus x square I have, that is 2 into 1 minus x by pi. 2 into 1 minus x by pi. Then again inside when I do for minus x, that I'll get minus 1 into dx. This is over. So that means, so this will be is equal to, when I substitute the upper limit, it will be 0. When I substitute the lower limit, this will be 0. Sin 0 is 0, even sin n pi is also 0. This entire term will become 0. Then come here. So minus minus will be plus. Then 2 came outside. Even by n also came outside. By n also came outside. Then what is remaining? 0 to pi sine of nx 1 minus x by pi dx. So from here what we conclude? So from here this will be the cosine transformation, that is n will be is equal to, then again by parts. So then again by parts. Okay. Then again by parts. So be careful here. What I did here. So here we need to do the differentiation of that. So when I do the differentiation of that I have 2 multiplied by 1 minus x. When I do inside x, 1 becomes 0, x become minus 1, then pi will be there. Don't forget this pi. So I will put completely outside this, that is n pi. Okay, fine. Now again by parts, no option. Then again by parts, 2 by n pi. So when I do the first term, 1 minus x by pi, this will be of minus n, then sine of nx with lower limit 0 and upper limit will be pi, then minus integration from 0 to pi, sine of integration of sine of n pi, that is minus minus will become plus, and I am sorry, this can't be the this is minus 1 by n. This is sine integration will be of cos of nx divided by minus n. So this you don't forget. So that means here also cos of nx divided by minus n into differentiation of 1 minus 1, that is minus 1 by pi into dx. So and of course close the bracket, because this term is a multiple of the entire factor. So now you see here, when I substitute the upper limit, so here pi will come 1 minus pi by pi, that is 1 minus 1 will be 0, upper limit will be 0, but lower limit will be contributing. So lower limit, when I put 0, this term will become 1, and this one will be cos 0 is 1, so that is only the term is remaining. So here it is 2 by n pi, then here it is coming as 1 by n. Here it is coming as 1 by n. Then what about here? So minus minus plus, that is 1 by n pi, cos nx will be is equal to sin nx. Now we substitute the limits from 0 to pi. Whether you substitute the upper limit or lower limit, in both the cases this will tends to 0. Sin n pi 0, sin 0 is 0. And finally cosine transformation will become 2 divided by n square pi. 2 divided by n square pi. As n square is coming in the numerator, we need to carefully here n can't be 0. So but n can be 1, 2, 3 and so on. So when n is 0, then how to solve? So when n is 0, so sine transformation anyway 0. But cosine transformation is non-zero. Cosine transformation is non-zero, because let's solve for when n is equal to 0 case. That is Fourier cosine transformation for 0. That is 0 to here the limits will be pi, the function 1 minus x by pi whole square. Then I have cos of n pi x by n. I'm sorry, n pi by pi, and of course dx. So pi will cancel. I have nx, but I am substituting n is equal to 0. n is equal to 0 I substitute, but cos of entire thing is 0, cos 0 will be of 1. Cos 0 is of 1. So okay, just a second. Yes. Now, with this, I have FC0 will be is equal to 0 to pi. I have the only one term is remaining, that is pi square into dx. It is somewhat like x power n, that is x power n is x power n plus 1 by n plus 1. That is f of c0 will be is equal to, so 1 minus x by pi, so cube divided by 3, then again by applying the chain rule, one differentiation is 0, then I have minus 1 by pi, that's it. But don't forget to put the limits from 0 to pi. Don't forget to put the limits from 0 to pi. So this pi goes out, then is f of 0 will be is equal to minus pi by 3. Pi goes up, minus pi by 3. I have the upper limit, when I substitute the pi, upper limit will become 0 minus lower limit when I substitute, that is 1 cube. So this is f of c0 will be is equal to pi by 3. So that means the function is given as f of x is 1 minus x by pi whole square, and they are asking the Fourier cosine transformation that will be written separately. This will be is equal to pi by 3 for n is equal to 0. And this will be is equal to 2 by pi n square for n is equal to 1, 2, 3 and so on. And be careful when you are solving for n is equal to when you are solving for n is equal to 0. So even in the previous sum also you can do in a similar manner. So even in the previous sum also you can do in the similar manner. So when I have n is equal to 0, see here in the previous sum, that is f of x is equal to x square. So f of x is equal to x square. Sine transformation and cosine transformation we did. So no issues with the sine transformation when there is a cosine transformation. First we did the sine transformation. Nothing issues with this. Okay. The cosine transformation. In the cosine transformation, n can't be 0. So that we have not taken here. Suppose n equal to 0, then what happens in this problem? So in this problem, we can't put here n is equal to 0. Obviously, n can't be 0. Because we have the term n equal to 0, that is cos n pi by n square is there. So n can be put from 1, 2, 3 and so on. So here what happens if I substitute for n is equal to 0? N is equal to 0. So that can be solved once again when there is a cos function will be there. So I'll help here. So at the end I'll solve here. Remember this, I'm writing again here. At the end I'll write here. Or otherwise if I have a space I can write at the left side. So let me write at the end, or yeah, I'll write at the end. I'll write at the end. I'll write at the end. That sum what we have taken, the function f of x is given as x square for 0 less than x less than 4. Then during the Fourier cosine transformation, so I have Fourier cosine transformation n will be is equal to 0 to 4 x square into cos of n pi x by 4 into dx. I need to validate for n is equal to 0. For n is equal to 0. So for n is equal to 0, cos 0 will be 1. For n equal to 0, cos 0 will be is equal to 1. Then what I have, only x square term is there. F of Cn will be is equal to 0 to 4 x square dx. That is x square integration will be x cube by 3, then 0 to 4 limits. So that will be upper limit will contribute, that is 64 divided by 3. Okay. So when you write for the complete function of the Fourier, therefore Fourier cosine transformation of the function f of x is equal to x square. Finally, we can write it will be 64 by 3 for n is equal to 0. Then this will be is equal to 128 divided by n square pi square for cos of n pi for n is equal to 1, 2, 3 and so on. Okay, be careful. Okay, fine. So this is way of solving Fourier sine and cosine transformations of the functions. So if you want, I will give you some problems to understand the Fourier sine and cosine transformations. So try at home. So for you, now I am asking you to determine find Fourier sine and cosine transform of first one f of x is equal to e power ax. The second one f of x is equal to sine of ax. Third one f of x is equal to cos of ax. Then exponential, like that many functions you can take. F of x will be is equal to x cube. Let's say in all the cases you take the limits from 0 to pi. In all the cases you take the limits from 0 to pi. So take in all the cases 0 less than x less than pi. The limits of integration will be 0 to pi. Okay, you try all these questions. Okay, fine. Thank you. I'll stop here. We'll do the rest in the next class. We'll take some more problems if needed regarding Fourier sine and cosine transformations. Okay, fine.